Hi guys, today we would be doing back titrations now. We are still on 1.5, okay? Perform calculations including the mole, using mole concepts involving volumes and concentrations of solutions, right? So it is, I told you we have acid-base, one, acid-base, acid and base titrations, and we have so far done the strong acid and strong base. Okay, now, okay. Today you will see as I do this back titration, you will see a strong acid. Or now we have done weak. Sorry, weak acid, and what is this? Strong base. Yeah, sorry about this. And strong base. Okay, now. Today in your back titration, we also do a strong acid and a weak base. The weak base is of course sodium, can be sodium carbonate or sodium hydrogen carbonate. Okay, right? So let's go straight ahead with the past questions, okay, and see how these things are asked. Page 292. Okay, on top of here, right? 291. What's happening? Sorry, 242. My eyes are blind. 242. Okay, right? Now look at here. Now, in all these things, you have to draw diagrams. See, it's a skill. Remember, it's a skill, not kill, okay? Skill. You will have to learn. Okay? So follow the methods I do, all right? So read the question first. Ammonium sulfate, NH4, 2SO4, is widely used as a fertilizer. In order to determine the percentage purity of a sample of ammonium sulfate fertilizers, was analyzed by reacting a known amount of with excess of NaOH and then titrating the unreacted NaOH with dilute HCl. Okay, now you can think about it later. Now let's see what happens now here. Okay, ammonium sulfate reacts with sodium hydroxide in the ratio of 1:2. So what was 1:2 here? It means here the ratio is 1:2. They tell you already. Okay, complete the balance and balance equation. Now remember, all ammonium salts, this you're done in your practical, all ammonium salts, okay? When you put a base and you heat it, base can be sodium hydroxide, potassium hydroxide, even calcium oxide, which is normally found in your fertilizers, and when you mix them two together in the farm, you know, right? You will give out ammonia gas, remember now. Okay, so heat. So the ammonia gets given out here, okay? So of course the remaining your salt is from sodium sulfate, all right? Plus of course water, H2O. To balance it, of course, look at here. Now there's one here, one more here, 2N, so put 2, right? Sodium 2 is it, right? Sulfate here. Now the water is a part here. How many hydrogens here? You got 2 hydrogens, and here come out 2 hydrogens, so 4. So 2 in front here, okay? So 2 water, 2 H2O, okay? So now this is done. Now next, a 5.00 gram sample of fertilizer containing ammonium sulfate was warmed in 58 cm3 of excess NaOH, okay, of 2.00 mole NaOH, right? When all the ammonia is driven off, the solution is cooled. The remaining NaOH is titrated with HCl. Okay, now here draw diagrams. Okay, first of all is draw diagrams. Okay, draw diagrams. I'm going to take 2 sessions now. Okay, so very simple. Okay, I'll put here first a beaker. Okay, so a beaker here you got what? You got NaOH, right? So what's the volume here? V1 is equals to 50.0 cm3. So as you read, you draw the diagrams, and the molarity M1 label 1, 2, 3 so that you won't get mixed up, 2.00 mole per dm cube. And here you put a container here. Okay, this is your what? It's your ammonium sulfate. Everything labeled in so you can see your drawing. A picture paints 1,000 words. Okay, here's the mass. How much is equals to? 5.00 grams. You put it inside. Remember, this will be in excess. Okay, right? So after cooling, say you drive off the ammonia, but you heat it on. Okay, right? You heat here. So after cooling, the remaining NaOH is still there, isn't it? Right? So the remaining NaOH was titrated. This amount here. Now this one here, you put down here. Okay, now here is the reacted. Okay, the volume here, let's say now V2, it is still 50.0, right? cm cube. The molarity you don't know because it has decreased there. This is NaOH. Huh? Okay, what do? You titrate. You put well, butane here, you titrate what? HCl. Okay, so how much HCl do you use? Here, right? With the molarity and the volume here. Since V2, you put now V3. How much you use? 31.2 cm cube. And what's my molarity of HCl? Given as well. How much is it? 1.00 molar. Okay? So let's do the question now. That means for complete neutralization of the remaining unreacted excess NaOH is this one here. Right? So now balance the equation very simple. NaOH plus what? HCl gives you, of course, salt and water only. The word only is very important. Okay, count the amount of moles of HCl in here. That means this is the one in here. Okay, so very simple. Number of moles is equals to MvO1000. Yes, now. Okay, so it's equals to, right? Molarity is 1 times 31.201,000. So of course it's equals to, remember here 3 zeros, 1, 2, 3, so 0.0312 moles. Okay, so the amount is a calculate amounts of NaOH present. Now this is in here before the reaction. Okay, now originate, this is before, or that means before reaction. How much you use in the beginning? Okay, very simple again. Number of moles, right? This very important. Number of moles equals to MvO1000. Yes, sir. Okay. So what's the molarity you use here? Given here is 2. Very easy. You can see here. Times volume is 50 or 1,000. Okay. So you do that, you will give you actually, calculate here it is 0.100 moles of NaOH. Okay. Now this is before reaction. Okay, so you can put down there in the answer thing here for yourself. Use your answers in 1, 2, and 3. Calculate the amount of moles in NaOH that is used up. That means that's reacted. Okay, it means that this is before. This is the now. Of course, here, right? Now the amount of NaOH present in here. Okay, how much here after reaction? Okay, right? So the current number of moles used up. Right now, that means the number of moles is unreacted of number of moles of NaOH. Okay, of course, it's the same as number of moles of HCl that is regular, right? Which is equal to how much? Here, all right, equals to 0.0312, right? So this is the one. Now, therefore, so the number of moles of NaOH reacted with your ammonium, with ammonium sulfate, equals to originally 0.100 minus 0.0 here, because there's a point there. 312. How much is it equals to? It's equals to 0.0688 moles. okay, or what? NaOH reacted, okay, with your ammonium sulfate. Okay, so now of course they will ask you for how much of ammonium sulfate. Use the answer in 4 an equation there calling the moles of ammonium sulfate reacted. Okay, now remember here, ratio, stoichiometry important. How many moles? 1 mole. 1 mole react with 2 moles. So okay, so how many moles of NaOH reacted? Is this one here? Okay, so let's put the equation first. Okay, always remember, you can use this one here, put number of moles of ammonium sulfate. Okay, I put like that so you won't get confused. SO4 over number of moles of NaOH is reacted. Okay, is equals to what? You can see from there, 1 over 2, is it? Right? From here, the ratio is 1, 1, and 2. So 1 over 2 here. 1 over 2. So how many moles of NaOH reacted? On top here, you can see here. Okay, 0.0688. So here would be the number of moles of ammonium sulfate reacted is equals to half times 0.0688. That's not, yeah? So it's equals to 0.0344 moles. Easy now, right? So you see, if you go backwards, you sort of calculate backwards. Use the answer in 5 to calculate the mass of reacted, okay, the mass. So very simple, mass, okay, number of moles equals to mass over mR, you know. So what's the mR of this whole thing? I don't know why it always got this problem. Okay, let's do it again. Okay, mR. Let's see. Okay, mR here. All right. So mass is equals to n times mR. So how many moles is it? 0.0344 times what's the mR of this one here? Now you can calculate yourself. Right? It's equals to, one is 132 times 132 equals to how much? It's equals to 4.54. You can do yourself now, okay? You can go back and do yourself, okay? I want to do faster for this 0.8, okay? Right? So, you know, the nearest number, of course, is 4.54, like I can say, grams, right? So, calculate the percentage purity of ammonium sulfate. Remember, percentage purity is equals to mass of pure substance over mass of sample. That means of sample. The sample means that the one that's got impurity as well, times 100. Okay, so 4.54 over 5 is not, right? 5.0. Okay, you can see here is 5. You don't know, look up here again. Don't be too smart. Okay, see here? Where's the 5? Here, 5, here, 5.00. Okay, so make sure here, over 5.0 times 100. Okay, so the answer is 90.82%. Okay, okay, all right, easy then. Okay, next one. Okay, we'll do a couple as much as we can, because sometimes you can go back and go do again, you don't do again, do as many as can. Perfect practice makes perfect. 2, 5, 8. Different one. Okay, now we have Chile salt. Petre or Peter is a mineral found in Chile and Peru, which mainly consists of sodium nitrate because it's used as a fertilizer, nitrate. Okay, the mineral is purified to concentrated sodium nitrate, which is used as a fertilizer and some fireworks. In order to find the purity of a sample of sodium nitrate, the compound is heated with NaOH, right, and develops alloy. Now this one is, you know, you done it in your practical, isn't it? Okay, that's for nitrates. Nitrates and nitrites. Okay, 2 of them, they put Devada's alloy. Devada's alloy, you know this theory, you must know this in your practical, okay? Devada's alloy is actually aluminum and magnesium and something is the whole thing. So aluminum is the active one here, and of course plus your NaOH. You hit the filler, you get what? You get ammonia now. Get ammonia. This is a test. You test ammonia, red litmus then turn blue. So this is what is happening here. So you can give the equation here, okay? Right? So it says contains aluminum. This reduces sodium nitrate to ammonia, all right? The ammonia, and it's boiled off. And then boil off, the ammonia boil off is now passed into acid, right? And dissolve it. Now you can do it like this. Okay, all right. Draw diagram. Okay, here you got all your things mixed up here. Okay, all this here. Sodium nitrate plus aluminum plus NaOH reaction, and you boil the filler, sorry. And what comes out here is your ammonia. All right. The ammonia is passed into here into sulfuric acid. Okay. Of a no, see the ammonia gas is dissolved in excess. Again. So here is your sulfuric acid H2SO4. Okay, excess means all your ammonia will dissolve. Okay, right? And this is the reaction. Ammonia plus sulfuric acid give you ammonium sulfate. Like going backwards, okay? So now after reaction there will be excess here. Okay, so the next step, of course, if I got here, all right, this is now, okay, this is the H2SO4 unreacted. Okay, so then what do I do? The amount of unreacted is then determined by back titration with NaOH. So I'm going to titrate now here. What with NaOH? Okay, of a known what? Of a known concentration. Of course, now this is the equation here. Okay, so there's equation 1, equation 2, and equation 3. Very important. Okay, so now here is step by step can see. So it says here, well, how did it all start? What is the values here? So it's 1.64 grams. They tell you here the procedure, okay? All right, the theory. Then they now tell you, hey, dear, now this is the practical stuff. So 1.64. So here, the mass is equal to 1.64 grams. Okay, of course, I put here sodium nitrate. Okay, right. Right, was reacted with excess Devada's alloy and ammonia produced here, we dissolve it. Here, this part here, okay, what's the volume of H2SO4? Now put V1 equals to 25.0 cm3, okay? What's my molarity given on? Yes, it's equals to 1.00 moles per dm3. Okay? When the ammonia was dissolved, the resulting solution was saturated with NaOH, right? I mean here. That means here, now here, remember, okay, the volume, let's say V2 is still 25. From here, same, right? From here, same. Okay, right? So now the amount of, now NaOH, how much of NaOH do we use? Okay, now here, the NaOH here, now this is V1, V2, isn't it? V1, so now I put here, now this V2, I put here V2, now V3. V3, how much did I use for your NaOH? 16.2. I should have put more space, okay? M3, molarity, what's molarity here? 2.0 is not, it's 2.0 NaOH, okay? 2.0, never mind. Okay, now comes the calculation. So you see in the picture, one whole stretch here. Calculate the amount of moles of H2SO4 present in 25.07 kg of here. That means originally, this one here. Okay? This before reacting what? Before reacting with what? With ammonia. Reacting with ammonia. Okay? So before, how much is it? Right? Because, okay, so very simple. Number of moles equals to what? NV over 1000. You always use this formula 1. What's the molarity? 1.00 times 25 over 1000. Okay, 1000 here. All right. So what's the answer here? Okay, because 1, 2, 3, 1, 1, 2, 3. So it's 0.0025 moles. Okay, of H2SO4 originally. Okay, then count the amount of NaOH present here. Okay, that means the one you titrate, is it? So same here, number of moles equals to NV. You always use this formula, so you make sure you know. Okay, so 2 times 16.2 or 1000. Okay, equals to, I put it here easier, 0.0324 moles. Okay, so now use the answer in 2 to calculate the amount of moles of H2SO4 that's reacted with your sign. So of course, now how to find how much reacted? Remember here. Okay, what's the ratio? 1:2. Okay, so of course you want to put number of moles of H2SO4 over number of moles of NaOH equals to 1/2. So number of moles of H2SO4 is equal to half of what? This is the amount right there, yeah? 0.0324. How much is it? It's equal to 0.0162. Yes, right? This is the amount of H2SO4 reacted. See your answers 1 and 3. Calculate the amount of moles of H2SO4 that's reacted with ammonia. Now this is the one that's reacted this one here. So what was the already before reaction is this thing, right? This is the one before reaction. Now this before reaction, this after reaction. That means excess. So how much of it is reacted with your ammonia? All right. So you can see from here. Okay. So okay. So original. So is 0. So number of moles of H2SO4 reacted. Okay, equals to number of moles before reaction is 0.025. Before minus what is left behind as excess, 0.0162, which is equals to, kill the mosquito first. Okay, which is equals to 0.0088. That's not. Okay? Right? So now this is the one reacted. Now the answer, of course, now is ammonia. So using the answer in 4, calculate the amount of ammonia reacted. Okay? It means now ammonia reacted with H2SO4. Now, of course, which equation use? Ammonia, here is it. Right? So 1 mole, that with 2 moles in ammonia. Okay, so, right? So here put number of moles of ammonia. Always put the subscript here. Number of moles of H2SO4. Okay? How much is it? 2:1, is it? Right? Okay, 2:1, 2 over 1. So how much is your H2SO4 there reacted? 0.0088. So it's equals to, so number of moles of ammonia reacted equals to this pen sometimes 2 times what's the number here? 0.008. Okay, times 0.0088. Okay, right? So it's equals to how much here? 0.0176 moles of ammonia. Use your answer in 5 to calculate the number of moles of sodium nitrite. Now, see, you go backwards here, right? So here you can see sodium nitrite here. Okay, so the ammonia is here. So it's 3 moles, produce 3 moles here. Yeah, same thing. So of course, you want to put the whole thing. 3 moles is to 8 moles is to 5 moles. Is to 18 moles, is to 3 moles, is to 8 moles. But you don't care about the rest. Here, okay, right, same, right? The number of moles is the same. Again, I don't know why this pen, this is playing me out. I don't know why again. Oh, I think I know why this is. Okay, draw. Okay, so now down here. Okay, so the number of moles of sodium nitrate over number of moles of ammonia, sorry, is 1:1. Actually 3:3 is not, so it doesn't matter. So the number of moles of sodium nitrate that is reacted equals to 1 times 0.0176, which is 0.0176. Okay, the number of moles of any yeah. Okay, so what's the mass here? Of course, number of moles equals to mass over mR, you know, right? So number of moles is 0.0176. Okay, right? 176 equals to m over mR. Now mR, of course, down here you can find yourself. I've done it. I've done my job. It's equals to 85. So mass is equals to 0.0176 times 85. Equals to how much? Equals to 1.496 grams. Okay, this is a pure sodium nitrate. Are you with me so far? Okay, so use the answer to calculate the percentage of mass of this one in your impure sample. Okay, suitable significant figure, very important. You can see how much they want there. So percentage. So yeah. So percentage of sodium nitrate. These are mass, always mass. Can you use moles? Mass of sodium nitrate over mass of sample. Okay, common sense is 0.5 times 100. How much is the mass? 1.496. We use the whole thing first. What is the mass of your sodium nitrate used? Is 1. You can check again, okay? 1.64 times 100. Okay, so what's the purity? You can see is 91.22%. Okay, now I put two check. Okay, what is the decimal place here? Okay, or how many significant figures here? Okay, you can see that here got 3 sig figures now. Okay, right? All 3 sig figures. Okay, all in 3 sig figures. Okay, 3 sig figures. So you put 3 sig figures answer. See? So it should be 3 significant figures. 91.2. Is it clear? Okay, because of 3 significant figures. You always check at what they give you. Is it clear? Right? Now this one you do yourself. Right? So finish number 2. Now let's go to the third example. Okay. 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 Let's look at 275. All these are a bit different. Okay. All are a bit different. So you can see. So they all are back titration, right? Remember, draw diagram first, equations all step by step. A sample of hydrated double salt. Some of you don't know what is double salt. Double salt means they got more than 1 cation or more than 1 anion. So it's copper 2 plus and ammonium. Yeah, there are 2 cations inside here. Don't worry, there are lots of things you don't know. There are in the world multiples amount of kind of salts. Okay, was boiled in excess. Okay, so again, ammonium salt. Okay, give it what? Ammonia. Same idea, isn't it? Ammonia produced was absorbed by now HCl instead of H2SO4. Okay, the resulting mixture requires so much of it's the same, isn't it? Right? So remember, if you want to draw a diagram, okay, now we draw a bit smaller. Okay, so we can fit more inside here. Okay, so what happens is that they say that, well, I got the sodium hydroxide here. Okay, here's NaOH. Okay, I put what? I put in the copper salt. Put it inside here, which is what the copper salt? Cu NH4, and you don't know what is X, right? You want to find X. Okay, sulfate, SO4, 2 and 6 water of moles of crystallization. Okay, so they react, right? So they boil, ammonia given off, Okay, NH3. And then this ammonia, all the ammonia is absorbed in what? In here, in your HCl. So ammonia produced absorbed in here. Now it is a HCl. HCl. And what information about HCl? The volume is this. So put down V1 equals to 40.0 cm cube. M1 equals to what? 0.400 cm cube. Okay, this of course will be before is always in excess because you want to react with all your ammonia, you know, okay? The resulting solution, that means the unreacted, okay? The unreacted HCl requires this amount of NaOH, okay? Then here, put on here, okay, come here. That means now got here. The volume is the same, okay? Unreacted HCl, okay? So the volume is the same, put 2 anyway, 40.0 cm cube. How much, what do you use to titrate? To find how much is left behind? Use your NaOH, okay, given here, right? Right? Okay, and how much is it? The volume. So V3 here, V2 here, so I put V3 equals to how much? What's the volume used here? 25.0 cm cube. And what is my molarity of my NaOH? 3 here equals to how much? 0.12 molar. Okay, can? So now they ask you get the marks here, right? Ion equation, you better know how to do it. Ammonium ions, okay? The reaction between ammonium ions and hydroxide is from your NaOH here, from NaOH. This is from your copper salt, isn't it? So put NH4. You must know how to do it. You don't know, learn by heart. Very simple. And you heat, must heat, okay? You give ammonia plus water. Okay. Okay, so 1 mole is to 1 mole. Got it? Okay. Calculate the amount of moles of HCl in here. That means calculate where? In original. This one here, before reaction. Here. Okay. Okay. So again, number of moles equals to MvO1000. You see, everything is the same. So I want you to see how I do it, and you make sure you don't need look, okay? Go back and do it, repeat again, repeat 2 or 3 times until you can get it by yourself. Otherwise, you learn nothing. 0.4 times 40 over 1000, okay, which is equals to 0.160 moles. Okay, moles here. Okay, right? 0.160 moles. Okay, make sure you correct. So you cancel this one. 1.6, correct? Okay, calculate the number of moles of NaOH required to neutralize the excess acid in this here. Okay, okay. So number of moles of NaOH. Again, MvO1000. See, you always have to use this equation. Okay, what's the molarity? 0.12 times what is the volume? 25 over 1000. Change to DN cube. Okay, so the answer here is 0.003 moles. Okay, I think here I got it wrong. 0.0. Okay, it's 0 here. Check it out. Okay. Right? Calculate the amount of HCl reacted with ammonia. Now this is before, right? This is excess. Right? Okay, so the number of moles of HCl reacted with ammonia reacted, okay, with ammonia. Okay, before is 0.0160 minus after reaction, the remaining excess is 0.003. So the answer here is, because I got it all calculated out, so it's easier for me. 0.013 moles. If I get wrong, I got to do it all over again. It's not easy, to tape it and then put a line, Malu Sajala is wrong. Okay, so it's the number of moles of HCl reacted. Okay, so now they ask you calculate the number of moles of ammonium ions in the presence. I go backwards here. Right? You can see here. There are the amount, the reaction here. Where is it? Okay. Well, I say here, okay. Ammonia HCl here, right? for here, this one here, I'm going to use blue color, that's so easier. Okay, so here, now this reaction here. So I'm going to find how much of ammonia is here. Okay, so we see here, right? Right? So how much of this is the amount of HCl reacted. So remember here, 1 mole of HCl react with 1 mole of ammonia, is it? Yep, that's what ammonium chloride. Yep. So 1:1. Okay, so they ask you for a number. So let's find out the number of moles of ammonia first. So number of moles of ammonia over number of moles of HCl is equals to 1/1. So number of moles of ammonia equals to, okay, bring HCl out. So 1 times the HCl rated 0.013. Same, 0.013 moles of ammonia. Which of course came from where? Came from the ammonium salts, you know. Remember ammonium salt? Plus OH minus, give you some plus water, is it? So 1 mole is 1 mole, is it? So of course same. So number of moles of ammonium salt, ammonium ion is the same. 0.013. Same. Okay? So now let's go to here. The sample containing 0.413 grams of copper. Okay, containing copper. This information, your answer to this part here, calculate the value of X. Now you got to learn carefully. You see, stoichiometry is very important. Now from this salt here, look guys, from this salt here. Okay, I'm going to put here. Now this I put Cu bracket NH4 bracket X. Okay, and find X in. SO4 bracket 2 dot 6H2O. Now if I would do like this, if I break it up, it give me here, right? See 1 mole of copper, plus X moles of ammonium ion, which is 2 plus here, plus 2 moles of sulfate ions, plus 6 moles of water. So remember 1 mole of copper will combine with X moles of ammonium ion. You see now? It's very important. That's why you know this stoichiometry will tell you, because it's 1 number. See it? Right? So now they tell you that the amount of copper here is 0.413. Again, play me out again. Let's change one. Okay, so number of moles now of copper will be 0.413 divided by 63.5. You can look it up, okay? Right? Okay, now here the number of moles of this one is given already, is 0.013 already. So this one here, remember, here is ammonium ion. So here they found it to be 0.013. Sorry, no, sorry. What am I doing? See, this thing is irritating me. Minuses. Okay, let's go here again. Okay, red. Now, okay, red, No, something to computer. Red. Okay, this one here is equals to, I found out to be 0.0065. See, I did all ahead of time, no. This is 0.013. So the ratio, moles ratio, divide this by 0.0065, divide it by 0.0065. How much is? 1:2. So it's X. So X is equals to 2. See? Right? So from here you can calculate the MR. Okay, I'm not going to do it for you. It's very simple. So the answer is Cu NH4 bracket 2 SO4. You don't have to go back to form 5. Okay, so calculate the MR. Can you do that? Okay, answer here. It's actually equal to 399.7. Okay, correct. Now, 2 questions done. All right, now, next one. So we're going to do about 6 or 7. So if time permits, if not, we do by 7. Okay, all the now a bit different. Okay, now no more ammonia already. Okay, 3, 6, 7. Right? Now watch, draw diagram, okay? Sorry. 0.17 grams of group 14 chloride. Okay, group 14, group 4. Okay, actually, the O is group 4. Carbon, silicon, germanium, whatever. Is lead, whatever, reacted with water to produce an oxide XO2 and HCl. Given here the equation. Okay, now the HCl produced was absorbed in, again, the HCl come out here, absorbed in this NaOH, which occurs reaction. Okay, acid base excess. That means the unreacted NaOH you will titrate again with some HCl one here. In a titration, the unreacted NaOH is required so much of HCl. So draw it out. You want to draw it out? Draw it out like that. Okay. So here you got. Okay, here's your water. H2O. And you put in your what? Here is your what? XCl4. And how much the mass is equal to how much? 0.17 grams. You put inside here. So what comes out? What comes out here? There's important HCl. HCl comes out. And of course, what you put here? To absorb all the HCl, put your NaOH. So here, V1. Whenever they give you a value like this, you put a V1. You label it down so at least you can see. You have to read 1,000 times, the molarity of your NaOH. So how much? 0.10 molar. Okay. Now this is the excess. This is your NaOH. The excess. Okay. So then the unreacted NaOH, right? See, in a titration, the unreacted NaOH here is titrated now. Okay. So you put down here. Okay, now here is my, what's the volume? Same, is it? This is your now the unreacted NaOH. Okay, volume is how much? This is V1. I put here now. I put V2 equals to same 100 cm cube. And molarity with different name, so I don't know now. Question mark here. So now I titrate. I want to find out how much is it. Okay, this is your HCl. And this HCl, how much I use? Okay, so the V2 here, put V3 now. How much equals to? 30.0 cm cube. And what's my molarity? Is equals to 0.20 molar. Okay, now. Okay, so you can see the whole picture at once, right? So you go backwards here, you go backwards here. Okay, the kind of thing. Okay, calculate the number of moles of HCl used in titrating neutralized, blah, blah, blah. Of course, this is the one now, right? Okay, so number of moles again equals to MV or 1000. So it's all same one. You just need to correct picture. Okay, 0.2 times the volume is 30 over 1000. Okay, which is equals to 0.006 moles. This is 0.006 moles of your what? Of your HCl. Okay, HCl. This HCl. Okay, right? Now, next one here. Write equation for the reaction. So simple. I tell you, any cow can do it. NaOH. Okay, form 3. You don't know, go back to form 4. I think form 4, form 3 you can do it. NaCl plus H2O. Okay. Current amount of sodium hydroxide neutralized this titration here. So here, this amount of HCl used. So why? 1 mole is to 1 mole, okay? So of course, you can put like that. Number of moles of NaOH. Always use ratio if you got a problem looking at direct ratioing. Never mind. This will be foolproof. You're a fool, then it's for you. Like me, I'm a fool. Equals to 1 times, what's the moles of HCl used? 0.006. So it's equals to 0.006. 0.006 moles of your NaOH. Okay? Okay, so kind of amount the moles of NaOH reacted with HCl. So originally, how much of NaOH is there? So originally, this is the okay, this before, you know, okay, right? Okay. So they ask you now how much of NaOH reacted with HCl. Okay, now this is the excess. So before reaction, number of moles of NaOH before reaction equals how much? Equals to, remember, 100 cm cube and 0.1 is it? 100. Okay, MV 1000. 0.1 times 100. Okay, right? This is the one here. All right. Okay. Let me have a look there. Over 100 here, 1000 here is equals to 0. See, cancel, 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 cancel. Here, 1, 2. So 0.01 moles. Yeah. So 0.01 moles here. Okay. So calculate the amount of HCl producing. Then remember this before reaction. So after reaction, how much is there behind this name? Right. So how much of it is reacted? How much of NaOH reacted? Okay. So here. So number of moles of NaOH reacted with HCl reacted is equals to before, right? Before is 0.01 minus after reaction 0.006. How much is it? 0.004, right? Okay, calculate the amount of moles of HCl produced. That means this one reacted with this thing. So NaOH plus HCl. So how many moles of HCl reacted? Same as it, right? NaCl plus H2O. So number of moles of HCl over number of moles of reacted NaOH is equals to 101. So number of moles of HCl is equals to same, 0.004. So 0. What am I talking? 0.004, correct. 0.004. Okay? Right? So now the final part. Calculate the number of moles of X Cl4 original here. Now, how many moles reacted here? Remember? Right? 1 mole. 1 mole react with 2 moles to 1 mole react with 2 moles, 1 mole is to 4 moles. So 4 moles of HCl come from 1 mole. So 1 is to 4, is it? So now this is the ratio, this is the mole ratio. So 1 mole. So here, remember, number of moles of X HCl, so X HCl4, and HCl equals to 1/4. That's not right. So how many moles of HCl was produced? This one, 0.004. So it should be, that means the number of moles, put a thing here, the number of moles of XCl4 equals to 1/4 times 0.004 equals to 0.001 moles. Okay? So number of moles of XHCl is XCl4, sorry, 0.001 mole. Now the important part here is to find a phone call. I think I would pause. Okay, now here. So the molecular mass, remember that there's a number of moles. So remember, number of moles equals to mass over mR. So what's the number of moles here? 0.001. Now what's the mass? What's the mass of your head of your use here? You can look up here. They tell you how much? 0.17. Okay. So here will be 0.17 over mR. So what's mR equals to? 0.17 divided by 0.001, which is equals to 170. Okay, 170. Right. So what is the relative molecular atomic mass of ArX? Very simple. Remember, XCl4 equals to 170. So X plus 4 times 35.5 equals to 170. This X plus here is equals to 112. It's equals to 170. So X is equals to 170 minus 112 is equals to 20. Sorry, 142 lah. What am I doing? 142. 142. Okay. See 35.5 times 4, isn't it? Right? 20. Here is 2022. Carry 1 here. 1. Okay. 12 times 12. Okay. 140. Okay. So X is equals to 28. 28, you can check it out. It's called silicon. That's fine. Okay. Again, see this. Okay. Now I think I can do 1 or 2 more. Okay. Okay, now let's do the next one. H369. Oh, next page here. That's nice. Okay, now here. 0.05 moles of group 2 metal was added to the HCl. Of course, you get hydrogen gas plus of salt. Okay, so step 1. Okay, now let's suddenly here they lead you step by step. So if you like, you can draw the diagram here. Okay. So HCl. HCl. And what's the volume here? V1 equals to 40.0 cm3. Okay? Molarity equals how much? 1.00 molar. And R. Again, no juice really. Okay. Okay. 1 molar. Okay. Right? So here, and you put in your M. This is M. What's the mass of M equals to 0.50. See the decimal points, okay? You put inside here. Okay, what come out here? Hydrogen gas. Okay? Of course, the excess acid one. It's always a back titration, is it? So number of moles of HCl before reaction, okay, at the very beginning, and again, MV 1000. Because I hope you're not bored now. I'm bored already. 40 or 1000. Okay. So here is equal to how much? 0.040 mole. So 0.0. This is before reaction. When the reaction is finished, the resultant solution was made up to, now remember here, okay, 100 cm3 in the volumetric flask. You do this very commonly in your practical. You put the whole thing inside here, 40 cm3, you put into a 100. Normally in your lab you use 250, isn't it? Now mine, here's your. So the V2 is goes to 100 cm3. Okay, put inside here, top it out with water, isn't it? So now this is the unreacted acid. You don't know what's the molarity now. This is a HCl, unreacted. You dilute it. Okay, so now it says, well, here you shake, 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 and then 10 cm3 of this solution. So you pip it out. Okay, you can draw all the things you want here. You pip it out here. I will draw it down here. Okay, how much you pip it out? 10 cm3. Okay, see, 10 cm3 of this sample of solution. So here I put now V3, 10.0 cm3 accurate here, and you titrate it with a weak base. That's what I'm telling you now, is sodium carbonate. Don't worry. Okay, so the volume is given and the molarity given here. So now V3, use a V4. How much is it? 15.0 cm3. Molarity is equals to 0.050 molar. Okay now, so for total neutralization, okay? So now the equation for complete reaction with sodium carbonate, so you need to write down here, Na2, this form 5 work out, or form 4 plus HCl for complete reaction. Of course, you use sodium chloride plus carbon dioxide, as you know, plus water, H2O. Okay, so 2 here, so put 2 here, okay? So 2 here, so, okay? carbonate, one because water is H2O. Okay? Calculate the amount in moles of sodium carbonate needed to react. Okay, of course, from here. Very simple. Again, number of moles equals to MV over 1000. Always remember this number of moles. Number of moles, number of moles, number of moles. Okay, 0.05 times volume is 15 over 1000. Yep. Okay. All right. That will be equals to, if you do it properly, is 7.5 times 10 to the power of minus 4. Okay, moles. You can put in this form or you can put in this one. This is easier, okay, standard form. Okay? All right. So next one, of course, here put the 7.5 times 10 to the power of minus 4. All right, next one here. Calculate the number, calculate the amount in moles of HCl in the 10 CFP. Remember this thing? So how much of HCl is here? Right? Now remember 1 mole of NaOH react with what? 1 mole of HCl. Yeah. Okay, the balance equation plus H2O. Right? So this amount of any some carbonate reacted. So how many moles here? Remember? Sorry, not this one. What am I doing? On top here. Sorry, here. I thought you was using NaOH. No, using a weak base now. Okay, draw. Okay, here. So 1 mole is to 2 moles, you know, right? Okay. So now this is your sodium carbonate. This is the number of moles of sodium carbonate. Better write here, otherwise I forget as well. So number of moles of HCl reacted over number of moles of sodium carbonate is equals to 2 over 1. So bring up here. So number of moles of HCl is 2 times 7.5 times 10 to the power minus 4. Right? Okay? Which is equals to 1.5 times 10 to the power of minus 3 moles, which is 1.5 10 to the power minus 3 moles. Okay? So, now remember this is the number of moles of HCl left unreacted, isn't it? Okay? So, this is current total number of moles of HCl remaining after reaction shown in equation 1. Okay? This is the one. Okay? Right? Which is same as this one here. Now remember this is in 10 cm cube now. But it came from where? Originally came from 100 Z. So here contains this, where is the third? This amount of moles. How about in 100 cm cube? That means before totally here. So here you can put down here. All right. 10 cm cube contains 1.5 times 10 to the power minus 3 moles of HCl. Therefore, 100 cm cube originally in the one here contains how much? Of course, times 10, 1.5 times 10 to the power minus 3 plus times 10. So 1.5 times 10 to the power minus 2. It's not. Okay, or you can put in 0.015, but you like to put 1. Right? So this is the amount of HCl on here, on this part here, that remains unreacted here. Okay? Right now. But the original is this one here. So how much reacted with the metal? Very simple. So here, use the answers A and blah blah blah. Calculate the amount of moles of it reacted. Okay. So before, so the number of moles of HCl reacted with M. Of course, before minus after, isn't it? Right? Before, how much do we use? 0.040. 0.04 minus how much remaining unreacted? 0.015. See here? Yep. Right now here I put down here so for easy calculation. So how much is here reacted? Here is equal to how much? Here is equal to 0.025 moles of HCl reacted with what? With your M. Okay now. So current number of moles, so it's 0.025. So use the answer in equation 1 to calculate the amount of moles of that here. Of course, now remember here they give the ratios. here. All right. Okay, so 1 mole here, rest it, 2 moles, Yep, that's 2. So from here you can find, you have found the number of moles HCl record, so now is M. So here, number of moles of M over number of moles of HCl is equal to 1 over 2. So this is the number of moles of HCl. So number of moles of M is equal to 1 over 2 times 0.025. Yes, not? Equals to 0.0125 moles. 0.0125 moles. Okay? Okay, this will be present in 5 grams. So calculate the MR, easy lah. You got the mass, this is a mass, you got the moles, you can find AR not. Of course, number of moles equals to mass over AR. Okay? So number of moles is what? 0.0125 equals to, what's the mass? The mass, of course, is, well, how much you use? How much you use? 0.5 is really, I also can forget. 0.50 over AR. Why AR? Because element. So AR is equals to up to 0.5 over 0.0125. Answer is 40. 40. So what is it? Calcium. Okay. Now I think my time is up here, right? I leave it to you to do the rest of it. It's quite simple, okay? Right? I give you the pages. The page, you can do the rest of this one here, the page. Or maybe we can do it next time. I don't want to take much of time. 2, 4, 5, there's 1. Okay, this is question 2. We see how we do next one, okay? There are 2, okay? And of course, there are actually there are 3 more questions I want to do with you, but time does not permit. And on page also 2, 5, 3, question 10. Now this one is what? This one is objective question. Maybe I do the objective question. Okay, I do this one. This one is a long question, and there's one more 2, 7, 8 also objective question. Okay, question 2. No, sorry, this is a long question. Okay, right? Oh, sorry, these are objective question 2. Okay, maybe I do this one here. All right, look at 2, 5, 2, 2, 5, 3. The rest you do yourself. 2, 5, 3. Okay, let's look at this question. This one is very simple. Remember, it's a weak base, 2, 5, 2, 5, 3, 2, 5, 3. 2, 5, 3. Okay, right? Okay, a washing powder contains sodium hydrogen carbonate. Now this is a weak base, guys. Weak base. Okay, I'm going to put here sodium hydrogen carbonate. Okay, it's one of the ingredients in titration, also containing 1. So this the mass here is equals to 1.00 grams. Okay, requires 7.15 cm3 of 0.1 molar of acid. Okay, plus H2SO4. Okay, and how much of it is used here? They tell you V1 is equals to 7.15 cm3, and of course M1 is equals to how much? Is equals to 0.100 molarity. Okay, a balance equation here, of course, is sodium sulfate plus carbon dioxide. You have to know, don't know means fail. Okay, 2 Na, so put 2 in front here. Okay, carbon dioxide here, 2 is it not? So 2 here. Okay, hydrogen 2, so 2 and 2 here, 4, so 2 here. Okay, learn a balance. Okay, don't have balance, you flung. Okay, carbon dioxide cannot. Okay, altogether here got 6 oxygen. So here's 4 plus 2. Okay, all right. So here, for complete reaction here, the sodium hydrogen carbonate is the only ingredient that reacts with acid. So what is the percentage of mass of sodium hydrogen carbonate in a washing powder? Very simple. So from a known to a known. So the number of moles of H2SO4 equals to MV again over 1000. Equals to how much here? 0.1 times 7.15 over 1000. Equals to, what's the answer? Here is 0. I'm going to put down, watch out, 0.00715. Okay, I'm going to put in this form. Okay, So now the number, you want to find the number of moles, right? The number of moles of this fellow here. Okay? So 2:1, isn't it? 2:1. So what's the number of moles of sodium hydrogen carbonate over the number of moles of H2SO4? Okay, equals to 2/1. So the number of moles of sodium hydrogen carbonate equals to 2 times the number of moles of your sulfur, say 0.000715, which is equals to, by the way, 1.43 times 10 to the power minus 3. Okay, so the mass, remember the mass of this one here, they ask for the mass, right? So the mass, so you'll find the mass. So very long calculation, only 1 mark. I tell you, not fair. Okay, so number of moles equals to mass over mR. You will find all these nonsense as well. So this is 1.43 times 10 to the power of minus 3 mass. Now the mR I found for this one here, the mR of this is I found for you already, is equals to, let me say, 84. So 84 here. So m, the mass is equals to 84 times 1.43 to the power minus 3, which is equals to, by the way, 0.12 gram. Not finished, no, because you want to find percentage there. Okay, so what's the percentage of sodium hydrogen carbonate? Now this is the mass of pure, this is the mass of pure sodium hydrogen carbonate. Okay, what's the original mass you use? 1 gram, isn't it? Okay, so 0.12 in 1 gram. So what's the percentage? Okay, I'm going to finish here. Okay, percentage of sodium hydrogen carbonate in, okay, equals to, of course, 0.12 over how much? 1 gram, is it? Times 100. How much is this? So it's 12%. What's the answer? 12%. It's percentage. Don't stop at that one there and then you get wrong. Okay, no? Okay. Okay, I think I will stop here, otherwise overshot time. Okay, guys, the next time we'll do it probably on redox reaction here. Okay, so we do a lot of these calculations. You have to go over all these questions, do it again and again until you get the hang of it. Because why? It comes out not only for paper 1, paper 2, and also practicals. Solutions is very important. So you have to do this. Okay. So goodbye. I want to stop recording now. Bye bye.